So, hello everyone, my name is Jean-Jean. I'm going to be presenting container security best practices. So I'm certified, got all of 5 base certifications, interested in security and privacy, working on various security papers that I'm hoping to publish later on in this year. And then I'm currently working on a number of security certifications. So kind of an intro to security, we kind of started off with the bare metal servers a long time ago, and that kind of transitioned into virtual machines that we could then deploy stuff on, and then we then transitioned into containers. And the benefit of this was so that we could separate our host layer from the hypervisor and have separate operating systems that didn't interact with one another. And containers give us additional flexibility where only the libraries that are necessary can reside in the container instead of having those libraries on the operating system. So one of the more popular container registries that we can use in container systems and orchestration systems is Docker. So you would create Docker images. There's a registry that you would register these images to, and then you can deploy that. And then Docker would take care of, or whatever orchestration system you were using would then take care of all of the networking and operating system changes that you needed. And there's a plethora of technologies that you can use. You can use OpenShift. Apache has a system called Mesos, so I'm not sure if that's the correct pronunciation, and Kubernetes, ECS, and Docker. And the big question then comes in is these containers, how do we secure them? So in a traditional IT world, we would have layered security. So we would have typically our instance sitting and our data sitting in the middle, and then we would add different controls on top of that. So from agents, data loss prevention, some kind of network segmentation, antivirus, etc. And the goal of this is so that our most privileged, most sensitive data is kind of in the middle, and then we wrap it with security controls around it so that even if one of those controls should fail, we would still be protected. So in the traditional world on an EC2 instance, we would harden the instance by configuring the operating system to behave in a specific way. We would also turn off specific features of that operating system. We would then install various agents for antivirus, endpoint protection, endpoint detection and response, data loss prevention, etc. And then our tools, so Python, the AWS CLI, potentially net tools to do debugging if you're working in an incident. And then this kind of raises an interesting question that when you work in a container world, how does this actually work out? And if you have these agents, where should you deploy them? So containers are deployed on a underlying host. And then the big question then becomes, do we deploy these agents and hardening inside the container, or on the host, or on both of them? And I can tell you that I work with quite a lot of security people in my job. I also work closely with other security consultants from various other companies, and nobody agrees on this. So our security architect would say, if you are doing DevOps correctly, you wouldn't need to have security in the container. However, application teams, especially immature application teams, tend to do very stupid things. They tend to pretend their containers are full-blown virtual machines. So you would typically find on an OpenShift cluster, you would find people running Ubuntu as a container, basically, but they treat it as a virtual machine. And then from a security perspective, how do we then secure not only the container, but the rest of the network that is now potentially at risk because of this one container that has been affected? So if we go back to the cattle and pets this analogy, so if we do containerization properly and we're using DevOps and we are creating these containers through some kind of CI/CD process, there's no need for us to harden the containers themselves, although that may be a good idea. So I guess our answer, or at least in most organizations, if you have immature to mature teams, is to do the hardening in both the container and the host. But what that does mean is that you get a lot of bloat in the environment, because your containers are meant to be this lightweight thing that you can then deploy wherever you need to. But then now, as you start doing hardening and adding your agents to it, you're actually breaking some of the container goals, the ideals that it has. So if you are going to harden your container, the CIS, which is the Center for Internet Security, they have a number of guides for specifically Docker containers, but other container technologies as well. And what this hardening would do, for example, is it would say certain security controls that you would need to meet. So what it would do is it would turn on things like SE Linux. It would use control groups to limit the resource utilization of each container. It will then it will increase the separation of those containers, so that if you do have a malicious container inside your cluster, it cannot attack other containers. On some platforms that is actually possible, where you can actually do you can actually read other containers memory. So that's something that you need to kind of think about. And then using Linux capabilities, so only use what you need and kind of switch off the rest of the stuff that you don't need. And then you should also be using secure computing mode, which basically restricts which system calls you can make to the underlying host. Then you also, if you are running containers, since this is an AWS meetup, you also need to make sure that the underlying infrastructure is secure. So on an account level, make sure your config CloudTrail is set up and that's been logged to an S3 bucket secured by KMS. Make sure you've got VPC flow logs turned on for your VPC. Make sure that you at least are logging what's going on inside of your application, either to CloudWatch or some other kind of logging tool. And then potentially look at using GuardDuty. So GuardDuty is a fairly new service, which is a managed threat detection tool for AWS. And what it will do is, if there's any malicious activity inside your EC2 instance or the containers running on top of your EC2 instances, it will alert you to that. And then, as kind of Martin pointed out, with some of the services that can use IAM roles, make sure that you are actually using IAM roles with instance profiles and not using access keys inside your containers. That's very bad practice. And then as you create these containers, make sure that you stay away from these, be very careful when you pull stuff from the Docker registry. So this was kind of recently where a bunch of people created a bunch of useful containers. So it was legitimate software, but there was also a crypto miner inside the container, and it was downloaded over 5 million times from the Docker registry and running on how many who knows how many hosts, but they made $90,000 in from mining Monero using these Docker containers. So it's very important to use trusted sources. Then if you, as you build these things through some kind of CI/CD pipeline, you really, one of the big things that you can do is scan your images for security and application vulnerabilities, and that's probably the number one thing that you can do to secure your Docker containers. And then to kind of take things further, you can look at actually signing your Docker images, especially if you are sharing them out to various places, and then you can actually verify that that what you're receiving is actually authentic. So, you know, vulnerabilities as our systems become more and more complex, the amount of vulnerabilities that we are seeing in our systems is increasing dramatically. Some vulnerabilities are kind of constant, but things like code execution, denial of service, buffer overflows is actually increasing quite rapidly. And these are fairly easy things to detect with the tools that we have today. So you can then use things like these are two open source tools, so DocScan and Falco, which will actually scan your containers for these vulnerabilities and give you a report on what you need to fix. AWS also has a tool called Inspector. They can also run inside your container to look for these kind of vulnerabilities. And then there are third-party commercial tools that you can use. So Tenable, you might know them. They make Nessus, the security scanner, or Twistlog, which also helps you visualize how the containers are related to one another. And then kind of the golden diamond standard, I guess, for container security is a company called Aqua, which has this entire platform and ecosystem for Docker or container security. And it can do all sorts of things like secret protection. It integrates with a lot of SIM platforms for security logging. It has SAML and SSO, so you can actually do some work with identity providers inside of your containers, and then it integrates with many other services. So one thing to keep in mind when you are building containers is that if you are using passwords in your files, that's not ideal. You should be putting that in some kind of store that you can then call on demand. So you can use HashiCorp Vault, which provides a very nice API to get the passwords that you need. But there's also the EC2 parameter store and as well as the secrets manager. And the difference between them is that the parameter store limits how many transactions you can do per second, and the secrets manager kind of is unlimited. AWS launched the parameter store first, and it was very useful for doing secrets management. And then I think they kind of got the notion that it was very useful to people, so they were like, yay, let's charge money for this and make a new service for this. So one of the core things that you need to do, whether you're running on Docker or Kubernetes, is make sure that you're not exposing your admin interfaces. So this company called Lacework did a scan of the internet, and they found 21,000 admin interfaces exposed to the public internet. And actually Tesla was one of those companies that had a Kubernetes cluster. The web interface to their cluster was actually exposed to the internet, and they actually were using the infrastructure to mine cryptocurrency. That was quickly detected and shut down, but it can happen to the best of companies. By default, I think Docker uses port 2375 and 2376, and then Kubernetes uses port 8080. Does that sound
Sure.
Sounds right? I don't know. And then also, I kind of think if you are exposing your ports, make sure that you are exposing the ports that you think you are exposing versus, And then this is kind of on the other side of the scale. When you're running very large clusters and very large containers that are processing high volumes of transactions, you can actually run out of entropy. Now, entropy is the randomness, so it's used when you use generating keys for SSL connections, and you can actually the way by default it works is that it will use dev/random, which is a random number generator, and if it runs out of randomness, it will actually block your containers from actually processing more information. So it's just something to keep in mind, is that you should instead of using dev/random, you should use dev/urandom, which doesn't block. And then I kind of feel the idea that you can run out of randomness is a bit strange. One of the things that you can also do potentially, and this is again, you can actually use an external source for your entropy inside of your container, especially if you are doing things with high security and cryptographic work, because when quantum computers come out, we all are screwed. And that's the end of my presentation. So thanks.